Here's a little secret project I've been working on. After a frustrating day at work, there's nothing quite like coming home and getting to sneak in a little time in the workshop. Here's a little secret project I've been working on. Plastic gear. Wow, where could you use a plastic gear on a lathe? Why, on a threading dial, of course. I don't have my bad gear here to show you, but it's almost completely wore out. And at work, we've purchased a 3D printer, and I'm trying to catch myself up with some technology that I've missed out on. And I've been printing gears, and this is kind of a difficult thing to master, but I'm finally starting to have some success. This gear here runs on my lead screw reliably. It's a little bit small, so I've got a new gear to try out. A little fixture there for holding on to the outside of my next gear to bore the center is not quite tight enough. Looks like I'm out at 242. This is a knurled shaft. Probably started out as a quarter. It looks like it's 252, 253, 250. Just depends on whether you get it between the knurls or on top of the knurls. Got to open that up just a little more. Seems to be opening up a little bit with each pass of the reamer. Remember, plastics tend to stretch around a tool bit. Mm, 244. So that's going to give me about 6,000ths press. I think that'll be fine. Sounds like a lot, but remember, it's plastic. Take a piece of music wire here. Try to knock this gear out. There we go. Now I made this aluminum jig here a bored hole to hold a slightly larger gear. And I've just sized this up with tape. Trying to drill the hole or enlarge the hole while maintaining the center between the teeth. I wrapped it in tape to get it to fit in my jig, which I made for a slightly larger gear. And I started the tape here at the mark and went around some number of times and then ended the tape over here, so I wouldn't have an extra layer of tape here that wasn't in any of the other positions clocked around the gear, just to increase the size of it so it would hold tight in my prior jig. Now I've had this in and out of the chuck, so it's not perfectly on center, but it's close enough for a plastic threading dial gear. So here's the gear I just took off of my threading dial. Perhaps you can see it herky-jerky moving a little bit here. It runs very reliably and never skips a tooth in here. It's the first gear I've made that does that. But what I notice is, and I don't know if I can show it well in the video here. Let me lower the gear here. The high point of the thread is kind of touching too early in the gully of the next tooth. It's kind of like the tooth hits the inside edge of the next thread instead of in the gap. So my teeth are just a little bit too close together. So I've made another gear, slightly larger pitch, and this gear seems to roll more smoothly on here to me. I feel a bump here and there, but I've got a little break-in procedure here. I have a feeling that this is going to end up being a nicer gear, probably the ideal gear. I'm still having some difficulty printing them with the correct ID hole. My holes are all coming out too small. So I've got some more to learn. Still learning about 3D printers. So let me show you how we install the new gear. Here's our threading dial. And we tap it on with a... No, we don't do that. You didn't believe that, did you? Have you caught the mistake? Let me show you the mistake. There's a timing issue. Let's look at these threading dials. I noticed on these Atlas Craftsman threading dials that this mark is not in the same place on each one. And the reason for that kind of will become clear here in a second. When I installed this last gear, I couldn't catch a thread right here. I could catch it about here, and I could catch a thread about here, but I couldn't catch it right on my mark. So there's a timing issue where that tooth needs to be in just the right position so that you can catch that mark. Now, how they do this in the factory, how they must do it in the factory, is this is unmarked. This is the gear that they make is pressed on here. It's installed on the lathe. The carriage is moved until the dial turns to 1, or probably just any even mark somewhere in the range of this plateau, and then they take a stamp and stamp a mark there, and then that becomes your mark. That's why this is a wide range. That's why these marks are in all different places on these lathes. So what I've got to do is actually mount this and try to find the position of the gear and kind of lightly hand press it on, and then we'll take it off and on the anvil and drive it together. Hope there's not too much glare. There's my mark. There's my number 1. It wouldn't have to be the number 1. Let me snug this up. Here's the gear I want to install. So I've got my number 1, or A mark in this case, lined up pretty well. See if I can get this lined up. There we go. Just kind of tilting the gear and feeling the teeth. Line these two things up. See if I can kind of hand start it. Okay, I got it hand started. See if I can not disturb it. This procedure would be the same, by the way, if you were installing a new gear or gear you made. Now, before anybody goes crazy, the gear is actually a little longer than the shaft. And I have to leave a little bit of play down here. I'm just going to eyeball it. I don't want to jam it against the housing and have it not want to turn. I could use a matchbook cover or something to prevent me from seating it out. And yes, this is the plastic hammer channel. And just a little more. There we go. Very little bit of play, maybe 15 thousandths. Let's install it on the machine and see how she runs. Okay, I've got it on the machine. I made a mistake in logic here. I didn't have this fully engaged, but apparently was engaged enough. If this handle were up, then this would not be in a fixed position relative to the lead screw. So the half nuts have to be engaged when you do this setup. Now, I've gotten it right, and it's off by maybe half a line width, which is plenty close enough for this purpose. And let's try it out. I hope you notice my lathe is a whole lot quieter. And of course the dial is not moving because we are feeding the carriage. Disengage the half nut and the dial is moving. Now I'm using an involute tooth gear, an involute tooth pattern, which the lead screw is an Acme thread. So these things are not perfect matches, and I'm not sure how they ground the original factory ones, but notice we've got a keyway coming around, and it's got a little bit of a sharp edge on it. So I'm going to put some pressure on it. You can hear the gear train struggling a little bit, and let it run in on this gear some. And in fact, I'm going to increase the speed of the lathe, the speed of the lead screw, and get it moving around more quickly. Go into the A gear range, and the 8 threads per inch position, but remember I've cut the feed speed of my lathe in half, so I'm actually at 16 threads per inch now, so it should be spinning quite a bit faster. Check that out. We can see we're not getting any skipped teeth. Some of my earlier versions of this would turn 2 or 3, 4 or 5 teeth and then skip a tooth. And what I intend to do is, this is going to be one of my little shop projects that helps fund and finance the tooling and stuff that I need. If you've got a Craftsman or an Atlas lathe and this gear is wore out down here, I don't know what the gear costs from Clausing, but it wouldn't surprise me if it was 40 or 50 bucks. But people will buy a used threading dial for about 30 bucks. And so I'm going to offer the gear at quite a discount to that number, and people can fix their own threading dials and not have to have a demand for the whole used units in the marketplace. The rest of it's always in perfect condition. It's just the gear. It's just the gear that wears out. So wow, I'm really pleased with that. And what I'm doing is loosening it and putting some pressure on it, because I want that keyway to keep taking a cut. And notice we have some plastic swarf here, and that's intentional. I've really driven that gear hard against the lead screw. I want to let that get a few minutes of running and really let the thread here match nicely to the lead screw. Now, in case the plastic is acting as a lubricant, I'm going to move this down to another section of the lead screw again. And I don't see too much evidence of plastic building up there. Well, that looks weird, doesn't it? When I go back this way to see the lead screw basically stop. So that ought to be enough running in. I'll take the pressure off this and just kind of engage it lightly, like I would if I was using it. Now the beautiful thing about this plastic lead screw, or lead gear, this should not ever wear this gear out. It should not contribute to wear in the gear. Alright, we're set up on the 10 here, which should give me 20 threads per inch. Alright. She's coming around here. Here's the one coming. Here's my hash mark. See if we can catch it. There you go. Perfect. We'll do the same thing on a half mark. Perfect. And number 2 is coming around the bend. Perfect. Don't be afraid to get your hands dirty and get out in your workshop and get something done. Be sure to like, share, and subscribe. It'll encourage me to continue.